Okay, so we are looking at Chapter 7 still, and we're looking at periodic trends in the periodic table. So at this time, please pause me and go get a periodic table, either from the front of your book or from an online source. Okay, so looking at the question, it asks, based on their positions in the periodic table, predict which atom of the following pairs will have the smaller first ionization energy. Okay, so ionization energy is the energy that is required to remove one electron from an atom. Okay, so looking at the table, just thinking about certain ions that you see commonly, like Cl minus. Okay, it's easy to ionize that. The energy is very small. So looking at A, what has a smaller first ionization energy? Remember that we don't want to remove the electron from the argon very easily. Okay, we don't want to. So for the first case, the chlorine is going to have the smaller ionization energy. Because we look at the trend, as you go from left to right, ionization energy will increase. Or you can also think of the fact that argon is a noble gas. And it's very, very hard to remove electrons from elements that have complete shells, complete electron shells. They're filled with electrons. Okay. Looking at the next example, beryllium versus calcium. Okay. So again, ionization energy, the amount of energy it'll take to remove a valence electron as you go down will decrease because your atoms are larger, the cloud is spread out over more space, and so the outermost valence electrons are not held very strongly. They're not held so strongly, so you can afford to remove the outermost electron without much of an energy penalty. So since calcium is in a lower row, that will have the small energy because it's larger, thus easier to remove an electron. Okay. Beryllium will hold on to those valence electrons much more tightly, so it's harder to remove from a beryllium. Okay, potassium and cobalt. So again, we're just looking at our trends. Ionization energy will increase going from left to right, as we saw before with chlorine and argon. Argon is more to the right, so it will have a greater IE. And potassium and cobalt, it's the same way. The ionization energy for cobalt will be greater than it will be for potassium because it's to the right. So it increases going left to right. So potassium will have the smaller energy. And you can also think of the I'm just going to redo this here. The pen is just a little bit messy. Think of the ion. Okay. K plus is how you always see it. So it's much easier to go to K plus than it is CO to take one electron off of cobalt. And you also know that because of the periodic trends. Okay, moving on to sulfur versus germanium. Again, we can use our periodic trend. So remember, IE will increase going from left to right. So germanium is farther to the left, so therefore it has a smaller ionization energy. you can compare. Now you might also notice that sulfur and germanium have different column and row, but the column is more different, has a greater effect. So our answer is D, GE. Because it's two columns away as compared to only one row away. Okay. And last one, tin versus tellurium. Find those in the periodic table, and again, we use periodic trends. So tin is farther to the left, therefore the ionization energy will be smaller, because ionization energy will increase going from left to right. Okay, so just use ionization energy trends. Okay, so make sure you study these periodic trends before your exam, and make sure that you have them in your head and you have a basic reasoning of why they go the way they go. Thanks for watching.